starting with the second lecture of double integration. In the first lecture of double integration, we have done the basics of double integration. There I have divided the questions or the types of question in 3 parts. I will provide that link of the first part of double integration in the description box. So if you haven't seen the video, do check it out. In this video, we will solve questions of those 3 types. So without further ado, let's start. So before starting with the questions, write this note down. It might help in solving the questions. So if we have this type, like double integration, region R is given, if function of x comma y dy dx, and R, the region, is given as x is greater than equal to a and less than equal to b, and y is greater than equal to c and less than equal to d. So in here, from this region part, we need to extract the limits here. So for extracting these limits, we will write, as we have seen, like here dx is given first, so we will be writing here the limits of y, then the limits of x here. So this will become, I'm writing the limits here only. Okay, so this will become from C to D and from A to B. Okay, so this is the first note. Then second point, if the question is given like this, find the value of integration for the region R, and double integration, a function of x and y is given and dy is given, and a graph will be provided with this. So then graph given here is f2 as a function of x, and this curve given is f1 as a function of x. So from this graph, we need to extract the limits. So the the limits here is given already from a to b, and from this one, since it will be cutting this curve, so the limit will be f1x and up till this to f2x. Okay, so now we need to write these limits here. So since we can see that these are variable limits and these are constant limits, and the variable limits are in form of x as a function of x, but the limits are of y. So first, here it is given dy also, so we will write the limits of y first. Then the constant limits we will write from a to b. Similarly, if the graph is given like this, and the question is same, like find the value of the integration for the region R for this integration, then we find the limits are given like this, a to b. Okay, a to b, this limit is b, and so here, and this limit will be g1y and this will be g2y, right? So here too we will write like this. Since the variable limits are g1y and g2y, so we will write that first. that is the limits of x first here. So g1y here and g2y in the upper limit, and then the constant limits, that is the limits of x here, a to b. So this was the types of question, or the like form in which the three types of the question which we have done might come. So I have just explained those things, and now we will start with the questions or the practice questions. So let's start. This is question number 1, and so we will solve it. You may also solve this question on your own and then verify the answer. It will be better, or obviously it will be better. So I will do it, but you first do it, then you verify the answer. Then that will help a lot. So I'm solving this question now. So in this question, we see the variable limits are given. That is here the limits of y, which is in terms of x. So therefore we will integrate with respect to dy. So here from 0 to 1, 0 to x, e to the power y by x dy dx. So let's move on to the next slide. So then we will integrate, and we know after integration it will be like this, e to the power y by x and 1 by x, 0 to x dx. So here we have applied this formula, integration of e to the power ax dx, where a is constant, is equals to e to the power ax by a. So similarly I have solved this like this. Then the next steps come like this. So I am putting the limits 0 to 1, e1 by 1 by x, e to the power 0 by 1 by x dx. So then integration over 0 to 1, ex dx, 0 to 1 x dx. Here e is constant obviously. So in the next slide again, here we will have e x square by 2, limits was from 0 to 1, and then x square by 2, 0 to 1. So after putting the limits, the final answer will be half into e minus 1, as e to the power 0, anything to the power 0 is always 1, right? So this is the question number 2, and you can pause and then solve it and then verify the answer. So here we go. Here also the limits are variable limits. You can see here they are variable limits. So these are the limits of x which are in terms of y. So limits of x, therefore we will integrate with respect to dx. Therefore it will become integration 0 to 1, and integration of dx only, because the other term is of y. So integration of dx only will be yx from 0 to root over 1 minus y square, and then dy, right? So in the next step I will be putting the limits. It will be equal to integration over 0 to 1, y into root over 1 by mine y square. Okay, dy. So here we will be substituting. We will substitute this 1 minus y square as t square. So I'm writing this here like let 1 minus y square equals to t square. Then only we can integrate, like it will be in the integrable form. So here we are differentiating with respect to y first. So this is constant, so it will be 0 minus 2y dy by dt and 2t. So this 2 and this 2 will cancel out, and it will be y dy, let me write it down, y dy equals to minus t dt. Okay, so now we will substitute these things in the next page in this equation, in this integration, and then we will write it like this. So here in place of this there will t square, therefore there will be a t here, right? And there we have y and dy here, and y and dy will be equal to minus t dt, right? So now we will be substituting this next slide, and we will write it like this: integration over minus t square dt. Yes, and since we have substituted, the limits of y will change to the limits of t. So here we have for y and t. So when y is equals to 1, t will be equals to 0, and when y is equals to 0, t is equals to 1. So t is equals to 1, right? How we are finding out this one? This we are finding it like this. Since we have substituted t square equals to 1 minus y square, so when the limits were 1 and 0 for y, so this 1 we are putting here, so t comes out to be 0, and this when y was equals to 0, we are putting y equals to 0, then t is equals to 1. So like this we are finding out the limits, and now I will be writing out this in form of limit here, 0 to 1. Then we will be integrating this like minus t cube by 3 from 0 to 1. And in the next slide, finally t cube by 3 1 to 0 minus there, and then we have minus of minus 1 by 3. The answer is 1 by 3, right? So this is the third question. You can pause it and then solve it and then verify the answer. So I'm starting here. In this question, if we observe that this is not in the form of integrable form, in any formulas we can't integrate, like, right? So we need to substitute here. We can see if we have memorized all the formulas of integration, then the substitution, it will obviously come into your mind by seeing this form only. So I'm just telling the substitution how you will do. Like here we need to substitute A is equals to root over 1 plus x square. We are substituting this, okay. So then let's write this integration in form of that. Then it becomes 0 to 1 integration of 0 to a. The variable limits also change. dy equals to a square plus y square, right? This changes into this form, right? Then we know the formula of this, so we will be writing that 0 to 1 by a, tan inverse of y by a, and from 0 to 0 to a, 0 to a, right? Then in the next step it will become from 0 to 1. We will be substituting the values of a here. Now in place of a we will be writing 1 plus x square, tan inverse of a by a is like root over 1 plus x square by root over 1 plus x square, so it will become 1, right? So integration 0 to 1 by root over 1 plus x square, tan inverse 1, inverse of 1, right? Sorry, I forgot to write the dx here, and the next step also. And then in the next slide we will solve this. Tan inverse 1 is pi by 4, so I'm writing it outside of the integration because it is a constant. Dx root over 1 plus x square. So we will be putting the formula here again, pi by 4 into log of x plus root over 1 plus x square, right? From 0 to 1. Then in the next slide we will be putting the 0 and the 1, that is limits. So if we were putting 0, log 0 pi by 4 log of 1 plus root over 2, and if we are putting here, we have put the 1, the upper limit, and then we are putting the lower limit, that is 0, that is log 0 plus root 1, that is log 1, which is 0, right? So the final answer will be this. So I'm erasing this part. So this is the answer. So this is the answer. Question. You can see this is the type 3 question, like in the previous lecture I have divided the question in 3 types, and the third type is this one, where the limits we have to extract it from these equations given, right? So here where the limits we have to put, we have to extract the limits from this equation. So we had divided this into 4 steps, right? Like in the first step we need to we need to draw the graph, then we need to identify the region, then we need to extract the limits, and then we need to integrate. So first we will draw the graph here. So here it is given y equals to x square and y equals to x. Y equals to x square, we know it represents a upper or upward parabola, and y equals to x is a straight line. So we will draw the graph here, upward parabola. So it will be like this, right? And so it will be like this. this is upward parabola, and y equals to x is a straight line passing through the origin like this. And y equals to x, again I have to draw, sorry, passing through the origin, right? So this is the region we need to integrate, like this is the graph, and now it had been given in the question that we need to integrate the double integration over the area bounded by the curves y equals to x square and y equals to x. Therefore the region will be this region. So now we can integrate this region. So to extract the limits, we can do it in two ways, we know. That is by extracting a horizontal strip and vertical strip. So here I am doing with the vertical strip. This strip I have taken. The upper limit here will be, since it is touching y equals to x, so the upper limit will be y equals to x, right? And here it will be cutting at the point 1 comma 1 and 0 comma 0, right? This you can find out like 1 comma 1 like this, y equals to x square it was given, right? So, and the other equation was y equals to x, so x equals to x square, so x square minus x equals to 0, then x equals to 0 and x equals to 1 we get, right? So from this 0 comma 0 we put the value of x, then we get 0 as the value of y, and when we put the value of x as 1 we get the value of y equals to 1. So 1 comma 1. So these are the points. So for this integration, so this is y equals to x, and this point it will be, since it is touching the parabola, upward parabola, which is in from the equation y equals to x square, therefore this limit will be y equals to x square, and the limits of x will be here from 0 to 1, right? So now in the next slide we will write the integration xy x plus y. So first we need to integrate the strip, then we need to integrate the strip over the region. So for integrating the strip, first we need to write the limits of the strip. So it's from here we see it's from x square to x, right? And then we need to integrate over the region from 0 to 1. So here we write from x square to x, 0 to 1. So now you have to just integrate 0 to 1, x square x square y dy plus x square x y square dy into dx, right? Then in the next slide we will have, if we are doing the integration here, 0 to 1 x square y square by 2 x square x plus x y cube by 3 from x square to x, right? Dx. Then we will integrate, we will get 0 to 1, 0 to 1, x to the power 4 by 2 by x cube by 2 plus x cube by 3 plus x to the power 7 by 3 dx. Then we have, in the next slide, we'll write half into x to the power 5 by 5 from 0 to 1 minus half into x to the power 7 by 7 from 0 to 1 plus x to the power 5 by 15 from 0 to 1 plus x to the power 7 by 21 from 0 to 1. So now we will be substituting the limits in the next page. So 1 by 10, 1 by 14 plus 1 by 15 plus 1 by 21. Then if we calculate, it is coming out to be 0.142. So this is the answer. I'm just writing this answer. So in the next question, it's question number 5. Let me write down the question. So this is the fifth number question. Here also the limits are not given. It is given in the region this one. From this graph, we need to find or extract the limits. So here we will again do the graph for this. Let's draw the graph first. So in the next slide, I'm drawing the graph. So this is the graph for x, y equals to 1. And then we will draw the graph for y equals to 0. Y equals to 0. It will be like, it is the x-axis, right? It is the x-axis. Y equals to 0 is x-axis. And y equals to x, we have to draw. And it is the line passing through the origin, right? And x equals to 2. So this is x equals to 2, let's say. Okay, so this is x equals to 2. This is y equals to x. This is xy equals to 1. And this is y equals to 0. So now we have to find the region. So bounded by this 4 graphs, the common region is this one. This one, right? This one. Right, this one. So now we have to integrate with this region, and now we will find out the limits, extract the limits from this graph. We can see in this question that first the graph is rising, then again falling. So the slope is first increasing and then the slope is decreasing. So here we can't integrate along this this way, from 0 to, let's say, this point, because then this region will be left out. So if we take this region, we need to divide this region here at this point. Then we will take the limits from this to this, again the other limit as from this to this, right? So now we will divide this region into 2 parts for our convenience, because we can't integrate like that, right? So here, and this point, we know this is the intersection point of y equals to x and xy. So this point P will become y 1 comma 1, obviously. P is 1 comma 1, this point. And then this point is then 1 comma 0, right? And this point we will have as, this point is cutting x equals to 2 and xy equals to 1, right? Then y will be equals to half here. So this point will be 2 comma half. So now we will have to integrate. So we have divided this region into 2 parts. So here we will have the integration like this. Okay. 0 to 1, 0 to x, x square plus y square dy dx plus from 1 to 2 0 to 1 by x, sorry, 0 to 1 by x, then we will have x square then we will have x square plus y square dy dx. So let me again explain the limits here. So for the first part we are taking the strip, this one, right, this strip. So for this one it is touching 0, and for this it is touching y equals to x. So for the first part of the region we have written from 0 to x for the strip, and then we need to integrate this strip from 0 to 1. So you have understood the first part. Then in the second part we have to take again a strip, this one, let's say. So again this is touching 0 at the bottom, or the lower limit, as a lower limit, and this one it is touching the curve xy equals to 1. So from there it will become 1 by x, right, and then the limit of the strip will be 0 to 1 by x, and then we need to integrate over this region. So it will be from here 1 to 2, the limits of x. These were the limits of y because we have taken the vertical strip. So here we have, I've explained this now. Now you just need to solve the integration. So let's solve. Like it will become, 0 to 1 x square y plus y cube 3, 0 to x dx plus 0 to 2 x square y plus y cube by 3, 1 to 2 it will be, right, 1 to 2, and 0 to 1 by x dx, right. So in the next page, or in the next slide, it will be like this: from 0 to 1 x cube plus x cube by 3 dx plus 1 to 2 x square by x square, x square by x plus 1 by 3 x cube dx. So then again, x to the power 4 by 4, 0 to 1 plus x to the power 4 by 12 plus x square by 2, 1 to 2 plus x to the power minus 2 by minus 2 into 3 minus 2 into 3 from 1 to 2. So if we put the limits here, it will be 1 by 4 plus 1 by 12 minus of 2 minus half minus 1 by 6, 1 by 4 minus 1 by 1, right. So from this, if you calculate, it will be, this will be the answer. So now I will be attaching more sums to this video. You will have to solve those on your own. If you have any problem in those question or in this question which I have solved, then do comment on this comment section, or you can DM me in the Instagram. I will be attaching the link of my Instagram in the description box. So do contact if you require any help or any confusion. You can also write in the comment section. I will solve it out. So now I will attach the questions. So do solve those questions too. And for the upcoming lectures, do follow the channel. Thank you.